Alright, so Chapter 10, Classifying Matter. We're going to be starting with Lesson 2, which is over physical properties. We're going to be doing the vocab for Lesson 1, so if it looks really long, that's why. So our vocab will be atom, compound, dissolve, and element is what we're going to start with. Make sure you pause these slides as needed. I'm not really going to read through them because we're going to talk through them in class. Next set will be matter, mixture, substance, and bond. Density, mass, and physical property will be our last three. Oh, excuse me. We also have property and solubility. And yes, I do know that is quite a bit. Like I said, it's going to be lesson 1 and 2, so hang in there when you're writing these down. Alright, so states of matter. This is getting into lesson 2. We're going to discuss 3 of the states of matter. That doesn't mean there's just 3, but we're only going to be discussing 3. Solids, liquids, and gases. I think you've probably heard of those. There's extra ones called, starting with plasma, ranging from, there's about 10 different ones when you start adding a lot of energy into things. But solids are vibrating molecules that are packed really, really close together, and they have constant shape and volume. So, when we think of things, normally we think of solids. I don't think you'll have a lot of trouble with this. What I want you to know is that solids, just because they don't look like they're moving, they're packed so close together that it looks like they're very still, or it looks like they're still, but they're still vibrating back and forth. They're just not quite as much as gas or liquid. So liquids, molecules flow past one another. They have more energy than solids. Molecules are further apart than solids, and they keep the same volume but can change shape, right? We've seen this before. Again, I don't think any of this is new. The only thing you're really going to maybe struggle with is the idea that we need to put energy into a liquid or into a solid to make it a liquid. When you think of melting something, so melting ice, you can heat the ice up to make it a liquid, and that heat is actually energy. And our last one, gases. Molecules have more energy than liquids. They move more rapidly. Both volume and shape will change in a gas. So we know that the volume of a gas is going to fill the room, whereas the volume of a liquid is going to just sit in the bottom of whatever container it's in. Again, it's going to have more energy than liquids. So if we're sticking with the ice idea, you have to put energy in to change ice, which is a solid, into water, which is a liquid, and then you have to put even more energy into the liquid water to make it water vapor. So that's what we're seeing here. Down here it says heat. I want you guys to start replacing heat in your head with energy. Energy and heat, are about the same thing, but there's other ways to add energy than just heat. So here we have our solid, which is going to be very, very rigid. Remember that these individual atoms and molecules move. And this has a constant shape. Our liquid doesn't have a shape, so if we shook this container up, then those atoms would move around, and here gas is expanding to fill the entire container. Size-dependent properties. Dependent means that these properties are affected by the amount of substance present. So take a second, think about what that means. So the more of the substance means that it's going to change these properties. So mass is the first one we're going to talk about. Its base unit is gram. Mass is the amount of matter in an object. So it would make sense that the more of the object that you have, the more matter there is. Remember that mass is not the same as weight. Weight is the amount of force that gravity pulls on an object. So this can change depending on where you're at. Mass does not change depending where you're at. So if I'm on the moon, my mass is going to be the same as if I'm on the Earth, but my weight would be different. Volume is the amount of space that a substance takes up. The base liter volume is base unit for the volume is the liter. We're going to be measuring a lot of things in milliliters instead of liters, but the base is the liter. So volume would be what we measure when we're measuring out water. We measure that in volume. Size independent properties. Independent means that it doesn't matter how much substance is present, they will stay the same. So these properties don't change regardless of how much of whatever we're talking about is present. So melting point is the temperature at which a substance in a solid state turns into a liquid state. It's different for each substance, and we can see this in our day-to-day lives. If everything had the same melting point, then everything would be liquid at the same time. Boiling point is the temperature at which a substance in a liquid turns to a gas state. Again, this is different for each substance. If everything had the same boiling point, everything would go from liquid to gas at the same temperature, which would be really, really inconvenient for us. Density is how many molecules are in a given space. Right here we're looking at the formula for density. D equals m over v. So density is equal to mass divided by volume. So again, mass would be in grams, volume in liters. So this might be a little more difficult for us to grasp. It depends, again, density is going to depend on each individual element or compound of what we're talking about. It's going to change with each of those. It's not, but remember, it's not going to change with the amount present, it's going to change with what is actually present. Conductivity is one that we're going to talk about very briefly. It's the ability to conduct or carry along either an electrical or thermal current. So electrical would be electricity, thermal would be a heat current. Metals are good conductors, woods and plastic are not. That's why, I mean, you don't want to be holding a golf club above your head in a lightning storm. Solubility is how easy a substance, or how easily a substance something can be dissolved. That's phrased poorly. I will make sure I get that changed. But solubility is how easily something can be dissolved. So things that are made to be dissolved, like Kool-Aid, things like that, dissolve very quickly in water especially. Other things like metal, if you've ever put metal in water, it doesn't dissolve very quickly. Separating mixtures. The property in an individual substance in a mixture do not change. So sugar and water still has the properties of sugar. By using the physical properties, you can separate mixtures. Salt and water. Okay, so you could use salt and water as an example here. Salt has a lower boiling point than water. So what we're talking about, and I think we might have talked about this in class a little bit, when we get to those salt flats, what happens is as the water starts to evaporate away, the salt has a higher boiling point, so it doesn't evaporate off. It stays in its solid form as the water is evaporated off. So we're left with just the salt and no water. Alright, that should do it for lesson 2.